See this problem. An Euclid triangle has a side length L. A charge plus Q is kept at the centroid of the triangle. P is a point on the perimeter of the triangle. The ratio of the minimum and maximum possible electric potentials for the point P is. Our motto is, so there is a equilateral triangle. Assume that it is A, B, C. So at the centroid we have kept a charge Q. So from this charge, because of this charge, you will get some different potentials on the perimeter of the triangle. So in those different potentials, the question is, what is the minimum potential and what is the maximum potential and ratio between those two, V minimum by V maximum. That is the thing we need to find out. Now I am going for investigate the given problem. That is, what are the quantities that have given. The charge is given. The charge is equal to Q, and the length of each side is given, that is L. Because it is an equilateral triangle, so every side is same. Now I am going to resolve it. So while resolving, I want to explain some concepts about equilateral triangle. So for that I am redrawing the equilateral triangle. So assume the equilateral triangle is ABC, and the centroid is the concurrent point of each median drawn from the vertices of the triangle. Let it be O. This median, this centroid will cut this median in 2:1 ratio. Now if you name these midpoints as X, Y and Z, so since it is a equilateral triangle, AB is equal to BC is equal to CA. This is one property, and another one is BX is equal to XC is equal to CZ is equal to ZA is equal to AY is equal to YB. Because all these are midpoints, so the distance to the vertices from the midpoints are same in all sections, like this. And one more, because the centroid is cutting each median in the ratio 2:1, so I can write like OA is equal to 2OX, OB is equal to 2OZ, and OC is equal to 2OY, and all these three are same. That means OA is equal to OB is equal to OC, and OX is equal to OZ is equal to OY. So this is the assumptions, not assumptions, these are the properties of an equilateral triangle. And now I want to write potential formula, electric potential formula around a charge V is equal to 1 by 4 pi epsilon naught Q by R, where R is the distance from the charge where you are going to find the potential. So if you see the equilateral triangle, the point X is having minimum distance from O when compared to any point on the line BC. So that means OX is having minimum distance, or X is having minimum distance from O when compared to the all points considered on the line BC. So if you consider any point on BC, those point will have more, for example consider Q, more distance when compared to OX. OQ is more than OX. OQ is greater than OX. That means OX is the minimum distance. And when compared to vertices distance also, vertices distance from centroid also, that means OC or OB. these distances are maximum when compared to any point which lies on the perimeter of this triangle. So if we consider OQ only, so OQ has less distance than OC or OB. That means all vertices are having maximum distance from the centroid, all midpoints are having minimum distance from the centroid. So then when come to the potential equation, so here 1 by 4 pi epsilon naught is a constant and Q is also considering as constant because only one charge is given. So here the varying thing is the distance from the charge. So V is proportional to 1 by R. So V is proportional to 1 by R in the sense when R is maximum, V is minimum. When R is minimum, V is maximum. So where we will get V minimum? You will get V minimum at C. You will get V maximum at X, C or B or A where the potential is minimum, X or Y or Z where the potential is maximum. So consider C and X points. V minimum divided by V maximum is equal to one by OC divided by 1 by OX using V is proportional to 1 by R formula. That is equal to OX by OC. That implies OX by OC is 2OX. So that is equal to 1 by 2. So that means V minimum by V maximum is equal to 1 by 2.